All right, everybody, we are going to pick up again where we left off. Can people hear me and see my slides?
Yes.
I hope. Great. Okay, so I am our next presenter. My name is Alison Marchione again. I'm a shoreland restoration ecologist with Vermont DEC. And I'm going to talk to you today about shoreland best management practices. I know we've already talked a lot about bioengineering and native plants, but I'm going to focus a little bit more on some of the smaller BMPs that can either be implemented by landowners themselves or be a small project on their own or be implemented as part of a larger project. And so BMPs are best management practices, and they're practices that are lake friendly and that when used allow for both reasonable lakeshore development and the protection of clean and healthy lakes. So why are we so concerned with using best management practices? I think Kelly gave a great overview of all the reasons why this morning. But, just to reiterate, 13% of Vermonters live within 250 feet of a lakeshore. Lakeshores have some of our densest development and if anywhere in the state, including our urban areas. There are more residences per square mile around lakeshores. And we also know that shoreline alteration is a higher indicator of biodiversity stress than eutrophication or acidification in northeastern lakes. And since the passing of the Shoreline Protection Act, which only happened in 2014, Vermont is in a period of shoreline restoration with a lot of attention being paid to water quality of our lakes and how shoreline best management can improve that water quality. So it's been sort of 10 years of focusing on how to better manage our shoreline development. A lot of BMPs focus on creating living shorelines. Living shorelines provide multiple benefits to all, and few would prefer poorer fishing, fewer loons, and algae blooms on their lakes. However, a lot of people who value wildlife and clean water also remove native vegetation off of their shorelines, which is one of the most important shoreland components for wildlife, water quality, and for property protection. So why use best management practices in shoreland areas? Shorelands are a very sensitive part of the landscape. And the very best shoreland practices will provide stable banks, protect water quality, and provide wildlife habitat. Shoreland best management practices help to restore and protect living shorelines. So this is very similar to a slide that Kelly showed us. This is a slide of traditional shoreline development. We know from Kelly's presentation and her NLA study that Vermont ranks worst in the nation for lakeshore disturbance because of extensive shoreland clearing that happened prior to 2014 and the Shoreline Protection Act. A lot of Vermont's lakes were developed heavily prior to 2014, and a lot of that development looks like these photos. With the development really close to the shoreline, very little vegetation, and some pretty poor stormwater practices. So we have had years and years and years of development that has not been good, and only about 10 years of any kind of regulated development on our shorelines. And we also know that when we develop properties, we change the hydrology of those properties. So take a look at the top left quadrant here. When we develop natural areas to include hardscapes and impervious surfaces, we reduce the ability of water to infiltrate into the ground. When water can't infiltrate into the ground, it runs over the ground, which is called runoff. The more impervious surface you create, the more runoff you will get. And you can see the different percentages of impervious surface in this image showing the higher percentages of runoff. Natural areas produce about 10% runoff, but we know that our developed lakeshores have more like 35 to 50% impervious, or sometimes even more, which creates about 30% runoff. And why is runoff bad? I think we've covered that today already, but it's because it can contain sediment and other pollutants that are bad for the health of the lake. It is okay for runoff to reach the lake eventually, but it is better for it to enter the lake through treatment systems that will remove sediments and pollutants first. So let's talk about this. What are lake-friendly practices? We're looking at practices that allow stormwater to slow down and infiltrate before it reaches the water. Practices that hold down banks and practices that create habitat, both terrestrial and in the water, are going to be even better for our shorelines. So a lot of us are probably familiar already with conventional or gray stormwater infrastructure. These are drains, catch basins, pipes, storm sewers, ditches, and culverts. These traditional stormwater management practices use a lot of structural controls to convey water away, but don't necessarily treat it. And then there are green stormwater infrastructure projects that, excuse me, are engineered practices that mimic natural hydrological features for infiltration, filtration, and conveyance. And they provide ecosystem services for flood control, water purification, carbon storage, temperature control, clean air, and habitat, variously. These are some examples of green stormwater infrastructure you might see in a more urban setting: stormwater tree pits, green roofs. These are usually not very suitable for rural lakeshore properties, but you might see things we're actually going to talk about later: pervious pavers and pavement, which are maybe more common. But generally speaking, for shoreland projects, we use a more low-tech vegetated shoreline BMPs to protect water quality, wildlife, bank stability. And you're going to see a theme over and over again in my presentation, and all day actually, of us really hitting on vegetation is one of the best ways to protect our shorelands. I have said, or we've said all day, we're going to talk about Lakewise, and there's really only one slide here about the Lakewise program. The Lakewise program is the non-regulatory sister program to the Shoreline Protection Act. It was started in 2013, just before the law was put into effect. Lakewise is an initiative of the Agency of Natural Resources. The program offers free stormwater management and erosion assessments that include technical assistance to lakeshore landowners, with the goal of establishing a culture of lakeshore land management that can improve stormwater practices and therefore water quality over time. The program assesses properties using 4 categories. Those categories are driveways, structure and septic, recreation areas, and the shoreland. And then the assessors make BMP recommendations to landowners to improve their stormwater management. I've sort of structured the discussion of different kinds of BMPs around those 4 areas. There's a lot more that I could say about the Lakewise program. I could do my whole half-hour presentation about it. So if you're interested in this program, please get in touch with me and we can talk about it, whether you're interested in becoming an assessor, if you're a natural resource professional, or if you're a homeowner looking to get a Lakewise assessment done. Again, it's a free, non-regulatory program that offers technical assistance. And also awards. I like to focus on the technical assistance part of the program, but the Lakewise program is an award program that awards really well-managed lakeshore properties in order to kind of influence neighbors on lakeshores into also getting assessments and making improvements on their properties. So let's talk about what some of these shoreland BMPs are. There are 2 main types. There are vegetative types that infiltrate, filter, and have the benefit of creating wildlife habitat, and then there are structural BMPs that do more infiltration and filtration without necessarily offering that wildlife habitat benefit. So when we're talking about driveways and private roads, you can see here some channelization on a private road or driveway. This is really something that is very commonly seen around lakeshores. In Vermont in general, over 70% of our roads are gravel, and around lakeshores, many lakeshore roads are private, so they're not maintained. They're maintained by the landowners. A lot of roads are very close to lakeshores, as we saw in Meg's presentation, and often driveways can be very steep on lakeshore properties because there's like a steep drop off towards the water. So a lot of people have issues with road erosion and driveway erosion. And there's several ways to address these issues. One of those is open top culverts. Open top culverts are a structural BMP that intercept runoff and redirect it into either a vegetated area or into a rock apron to be filtered and infiltrated into the ground. These are some open top culverts that were installed at the Lake Eden Fish and Wildlife Access Area a few summers ago. So before these were in there, the water coming off of a state highway was just barreling towards the lake down this access area, and these open top culverts were put in to intercept and slow down that water and shoot it out to the left there into a vegetated area. Open top culverts do require some maintenance, annual at least maintenance to clear them of built up sediment. And a lot of landowners, especially ones that have a year-round residence, or at least that get their driveways plowed in the winter, worry about how the plow will interact with them. And, if they're built properly and set in properly, the plow should be able to go right over the top of them. However, that's not always the case. So for some people, we recommend things that are more like this decorative water bar that might be more flush with the driveway. It can also be used in like a concrete or asphalt driveway. And it does the same thing. It intercepts the water. Remember that, water coming down a driveway, it's not the volume of the water that causes the erosion necessarily, it's the velocity at which that water is moving. So water bars like this will intercept that erosive water and slow it down and then redirect it into a treatment area. Another best management practices would be creating infiltration areas around your parking or your driveway, and also defining those areas or using that infiltration area to define that area. Infiltration areas help to absorb water from the parking area, and defining a parking area can reduce compaction. I think we've all seen sort of that like sprawling dooryard where you can fit, 1 car or 12 cars, and it just gets driven all over. And being able to define parking areas really helps to avoid that kind of compaction. So structures, what we're really looking at when we talk about structures is how much of the property is impervious and how much the stormwater is moving off the roof and across the property. In this photo, we can see a gutter downspout that is just like pouring water onto the ground, which is causing a really muddy, yucky mess. This is both not good for the foundation of the house, but this water is also going to end up running into the lake. So when we're talking about downspouts and gutters, gutters are not as common in Vermont as they are in other places because they can be difficult to maintain with heavy snow load and potential for ice buildup, but some people do use them. And the solution for dealing with the downspout like that could be a dry well that can sink and infiltrate the water. So that's coming out of the downspout. And so could releasing that downspout into a vegetated area that's more ready to absorb the water before it heads across the lawn. Downspouts can also be connected to rain barrels in situations where that's appropriate, where someone's actually going to use the water that comes out of the rain barrel. Often those get used for like watering perennial gardens or things like that, or vegetable gardens. And in addition to dealing with gutters, water from a roof line without gutters can also cause problems. And so in these instances, drip line trenches work really well to infiltrate the roof runoff by providing a place for the water to be absorbed. These are becoming a lot more common around lakeshore properties, and a lot of new builds will already incorporate them. So this is a picture of a terrible and undersized rain garden. You can see that there is standing water in it, which there shouldn't be, and it's also placed way too close to the house, and it's trapping water near the foundation. So most BMPs are designed for the 1-inch rainfall because 90% of our storms are 1 inch or less, at least, right now. I'm sure that that average will be more and more in the future. And so we can calculate based on the square footage of the impervious surface, how much volume of the stormwater will run off. And then we can size the BMP to treat that volume. For example, 1,000 square feet of impervious surface, which might be, the roof runoff to this gutter, based on a 1-inch rainstorm would generate 620 gallons of water. That's 124 5-gallon buckets, and way more than this rain garden was going to absorb. So it's important when sizing projects to size them appropriately and also place them appropriately. This is an image of some better placement of a rain garden. It's a little bit downhill from the house. It's in a depression in the yard, and it is much larger in order to hold much more water. These are just some lovely pictures of rain gardens. I think sometimes people have an idea that when you talk about both like rain gardens, BMPs, native plants, that it's going to have to be sort of ugly. And it's just not the case. A lot of rain gardens can be very beautiful. They can be a pretty perennial garden feature of a lawn. This is Lake Carmi, in case anyone was wondering. So there are a couple of sizing tools available. Learning how to appropriately size rain gardens is important to making sure that they are functional. UVM Sea Grant has a great rain garden manual that has a lot of information on calculating size based on drainage area, soil type, and slope. That also includes a lot of information about native plants to use and includes planting templates. That link is available in this PDF later. And there's also the Vermont Green Stormwater Infrastructure Simplified Sizing Tool for small projects, which is also available online and can help size out a variety of small projects. I'm going to talk really briefly about some septic stuff. I'm not a wastewater expert by any means, but I get asked about septic and wastewater issues on lakeshores all of the time. And if people have a lot of questions about this or concerns about their own property, please reach out to our wastewater division to talk about septic systems. And if your living on a lakeshore and have questions about this, I really encourage you to do a wastewater workshop with the wastewater division, because they'll have a lot more information than I do. But I do want to talk about just a few different sort of septic strategies for small spaces, because a lot of lakeshore lots are often very, very small, and we're coming up on sort of a tipping point of a lot of those systems are going to, in the future, need to be replaced. So, in those cases, we have to consider alternative strategies to deal with septic issues. So this example is a raised sand filter for tight spaces. This is a PVC-lined concrete box filled with sand. The effluent is pumped in under low pressure through pipes in controlled doses that ensure uniform distribution. And then the effluent leaves the pipes and trickles down. And there's a bunch more details about this that I'm not even going to talk about because I don't know what I'm saying. There's also minimal disturbance systems and drip line technologies that can be installed to work on steep slopes. And these wastewater systems are time dosed into drip irrigation distribution systems after it's filtered, and they can be installed as shallowly as 6 inches deep. You can also run these drip trenches among trees, which might be one way of preserving some mature trees. I've heard varying reports of how well this actually works, but it can be done. So those are just a couple instances and examples of alternative septic systems. So our next area that we look at usually is the lawn and recreation area. And in that, we're really looking at, like, where is the property getting used? How compacted is the soil? You know, is there a way to put in pathways? Is there a way to increase vegetation? These areas often will get compacted with a lot of use or sprawling use, which can increase untreated runoff into the lake. I think, you know, I'll say it again, but it's been said a bunch of times already today. Grass is a really bad infiltration system. Water runs right over it. The roots are really shallow. And so we're looking to reduce compaction and avoid runoff. So we recommend creating pathways. This is important on all types of lakeshore properties, but it's especially important on sort of like your public beaches or state parks and things like that, where you want to sort of show people where they should go. Obviously, same problem with driveways. If you have something that's a straight shot down to the lake, it's probably like down a steep slope. It's going to get eroded like this. And so one of the ways to maintain those pathways is to use water bars, open top culverts again. Or, you know, even best case scenario would be to reroute pathways like this so that they meander more and they don't just go straight down to the lake. There's also, here's an example of some permeable pavers that were used at Silver Lake State Park in Barnard. Eric Mootz from Travel Trade Suppliers will be discussing these systems later this afternoon, so I'm not going to get too much into it, but this did help to Silver Lake State Park to create an ADA compliant walkway. Another commonly used BMP are infiltration steps. They help prevent erosion and runoff on steep slopes, and in some cases, they can also help direct some roof runoff, as well as direct foot traffic and minimize trampling of the bank. So these are used often around houses with steep walkways to get down to the water or to get down to the water themselves on the shoreline. And then, of course, you know, we want to add more vegetation. I'm sure you're shocked to hear it, but you can see here's a design idea to move from just sort of an open, empty lawn area to a lawn that includes a meandering pathway, vegetation, and rain gardens to absorb that stormwater. It is important this is important as it maintains a usable recreation area. You still see the kayaks and the chair and everything like that. But the overall lawn runoff is reduced by creating more vegetated and permeable areas. This is another example of rain gardens and plantings and pathways and how they can be helpful for reducing compacted areas and for increasing infiltration. It also looks a lot nicer than just having that sort of bare, compacted ground. And we also see persistent problems with beach erosion. This, again, often is on town beaches or state parks, but it can happen also on private homes that have sort of a sandy, beachy area. So one persistent problem we see a lot of is beach erosion, especially on those beaches that are not naturally sandy. So they're bringing in sand and they're adding it to the beach. Usually that means, yeah, the sand is being added. So on this site, road runoff was coming down a slope towards a town beach, and water was running right from the road over the lawn and into the sand. The sand is easily erodible, and so it was being washed off the beach and into the lake. So what was the solution here? How do you stop, the water from reaching the beach? Well, in this instance, we created a stabilized buffer to protect the beach from road runoff. And there are a few other methods that could have been used, but in this case, we did decide to use a vegetated buffer at the top of the beach between the lawn and the sand to provide a barrier to slow and absorb the stormwater before it ever reached the sand. The beach is now buffered to intercept the road runoff and to protect the beach area from erosion. We also staggered the buffer overlapped the two ends so that it would allow people to pass through, but geese, which were also a problem on this lawn because geese love lawns, they love them. They don't see this opening and they only see one continuous barrier. And so they became uninterested because geese are lazy. They don't like vegetation. They like things easy. And there's a lot of lawns on a lake to pick from. So they went and picked somebody else's lawn. If you have beach geese issues, I highly suggest using a vegetated buffer to keep them off your lawn. This is another example of a similar project at the Raponda Town Beach in Wilmington. It was installed in, 4 years before 2021. I was here this summer and it has grown up really well. It's still intact. A lot of stormwater BMPs were used on this property, not just this beach buffer, but it has done a good job of preventing the kind of erosion that you see in the first slide here. And so finally, the shorefront. We've talked a lot about all the different upland stormwater problems that a property can have. Those problems often compound and sort of make themselves known on the shoreline. And so we see a lot of lawn to lake, a lot of conversion of natural shorelines to lawn, and it almost always ends up with some shoreline erosion issues. So, in many cases, we recommend that property owners revegetate their shorelines. And this can be done a couple different ways. Buffer plantings are a common, popular one. This can be a really effective way to revegetate the shoreline. So in this top picture, you can see a shoreline without much slope, but still a little bit of erosion and a buffer planting in process of taking place there. On the picture below that, you can see a before and after of a shoreline planting project. I think there was also some regrading and that sort of thing involved in this project because it is a pretty steep drop off. And you can see some of the, erosion control matting and things like that Meg talked about during her presentation. But another way to deal with this that is still planting is if you have smaller areas of erosion happening on a steep slope, and especially if those areas are a little bit more difficult to get to, or if you would have to take out a bunch of vegetation in order to get to them. We use willow staking often to stabilize the soil. This can be done in a really low-tech way. I think Meg talked about it a little bit in her presentation as well, but you can do this all by hand. And it's pretty inexpensive and it can be done by volunteers. So the willow stakes have naturally high levels of rooting hormone in them, and their fast-growing roots will allow for them to take hold really quickly and stabilize the soil. And especially if you're working in sort of a small concentrated area, this can be really effective. These are just some examples of vegetated shorelines that I thought were really nice and I wanted to share. Yeah, it can look really nice. It can be really beautiful. And you can still have your dock. You can still have your sitting area. You can still have, you can pretty much work around whatever it is that you want to have in a lawn area and create a beautiful vegetated shoreline around it. Here's some happy people on Echo Lake in Charlestown who have one of the most beautiful vegetated shorelines that I've ever seen. And I get a lot of questions when I talk about the Lakewise program about people who have retaining walls or seawalls or any kind of hardscaping in their yard who think that they are not able to get the LakeWise Award because of it. And that is, in fact, not true. There are a lot of changes and improvements that can be made to a property upland of the shoreline and on sections of the shoreline that don't have a retaining wall that can allow for people to get a LakeWise Award. I wish I had a picture of this property from the water, because it really shows what you can do even with the retaining wall and other hardscaping. I'm going to get one next summer. So I just wanted to give that as a beautiful example of a really well-maintained property. And finally, say that you don't actually have to plant your property. You don't have to spend any money on your property. This is a picture of a property on Lake Iroquois in Williston that implemented a no-mow area. It may actually be a similar property to the one that Annie showed, where you can do nothing. You can stop mowing your lawn. You can be really lazy like me during the summer and just let it grow up. And that's a free way to revegetate your property that is low cost and low maintenance and really low effort. So I'm always trying to convince people to go no mow on their lawns. And that is my presentation for you today on best management practices. I am happy to take questions now, if there are any. And I guess I'm going to moderate my own questions.
I can, if you'd like, Allison, I could take a look and.
It looks like there's only two. So there's a question about, I thought Vermont only allowed 2 types of septic wastewater treatment, your typical system with a minimum of 4 feet of permeable soil, or a mound system. Have the rules changed? So the wastewater division, I believe, does permit alternative and innovative septic systems. I can put a link in the chat to their website that talks about that. Again, I'm not a wastewater expert, so I don't know exactly the ins and outs of those rules. Yes, Perry, a septic social. We don't call them that anymore. We call them wastewater workshops, but they are a great way to get people interested in talking about septic systems. I really encourage any lakeshore community who's interested to do that. Tom, who supplies willows for staking? That's a good question. I don't know where you can get them. I've always had a source like available, because you can take branches off an existing willow and plant those. So that's how I've always done it. I'm not sure if there are. I'm sure there are places where you can.
I know you can get them from the Intervale.
There you go. There's one. Mm-hmm. So those are, either it's like a DIY kind of project where you've got a lot of willows available to take branches from and replant them, or someplace like Intervale and maybe other conservation nurseries might have something like that. Are there funding and grants available for this type of work? The short answer is yes. The longer answer is it probably depends on the project and the benefits of the project. So we're going to talk a little bit more about funding right after this. After I finish answering questions, we're going to get into a whole presentation about the different ways to fund some of these projects. For things that are smaller projects or things that are really like property protection projects, they might not get state funding, but if they have phosphorus reduction or wildlife habitat benefits, then they would likely be eligible for some of the funding we're going to talk about in just a few minutes. What material was the first open-topped culvert made of? They're wood. So they're, I don't know what dimension of lumber, but you can make, they're not very hard to make. So they're wood on the bottom and the 2 sides, and then they usually have like rebar or some sort of metal pole holding them open. And that's how they're made. I'll put a link in the chat after this also of a LakeWise fact sheet on how to build open top culverts. Any discussion on the timing of securing the live stakes would be helpful. Timing of their ability has been challenging for us. So the timing of securing the stakes, like getting them from a supplier, is that the question? Heather?
Yeah, sorry, I was trying to unmute myself. Yes, we have sometimes wanted to include live stakes on our projects, but the projects go out with like a certain schedule and, contractors wrapping up the project in a time of the year where those live stakes don't seem to be as available. If it's over the summer or even, I don't know, September or even early October, and the project has a contract completion date, so the contractor has to finish their work, and the landscaping and putting in the live stakes is usually one of the last things that they can do because the rest of the project needs to be built. And it becomes challenging because it's hard to find live stakes that are available while the growing season is still happening. That's my understanding anyway, that they're supposed to be dormant when they get installed. And if you have any experience with finding them and making sure they're available and different times of years that you're able to do that, that would be helpful to know.
So I've only done live staking projects mainly in the spring, which is, again, like I said, I've been, taking them off of willows and putting them in the ground in the springtime. But does anyone else on this call have experience with sourcing these and putting them in at the appropriate time? Because it seems like it's more of a supply issue than anything else. Patrick, I saw you unmuted yourself.
Yeah, I just threw a thought. Most of the time when you're installing live stakes in the summer, they should be kept dormant in like a cooler or freezer, collected dormant, processed, put in the cooler, put in the freezer in the dark, brought out, soaked a couple days before installation. And if it's midsummer, they'll probably root and shoot and grow and survive. Later in the summer, you might just want to extend your contract date and allow the contractor to come back in late October, early November, and install them then.
And there's some other notes in the chat about how the intervale sale. It does seem like the spring and the fall are the times when you can acquire them. And then, like Patrick said, preserve them until it's time to plant. So hopefully that information is helpful. And then there are just some more comments here about innovative and alternative septic systems with some links. So I guess I don't have to do that, which is thank you for your help. All right. Any other questions for me, or we will move along to our next presenter. And some other people suggesting places to get willow stakes. Great. Keep putting stuff in the comments. Otherwise, I will stop sharing and introduce our next presenter, who's Ben Copans. He's a tactical basin planner for Vermont DEC, and he's going to talk to you all about the question you've been asking all day. What is the funding for these projects? Thanks, Ben. You're muted. No, you're still muted. So, Ben, we can't hear you. I don't know if you know that. Do you maybe want to sign off and sign back on? That's helped some people.
Okay. Can you hear me now?
Yes. Okay, great.
Sorry, my computer froze on me, so apologize for the delay here. But seems to be working now. So I'm Ben Copans, watershed planner with the Water Investment Division. And I'm going to talk through a little bit about some of the funding opportunities for our clean water projects. And let's see here if things are going to work for me. So going to talk a little bit about the partnerships and some of the technical support for getting some of these projects funded. Talk about some of the funding sources. So we have two main funding sources for these lakeshore projects, our enhancement grants and formula grants. And then going to be talking about the different project types and something that we need to dive into if you want to get some of the formula grant funding, which is the phosphorus reduction calculations. So I wanted to start out with a discussion of the lakeshore project life cycle. So in my experience, these lakeshore projects often start from two different areas. Either you have a landowner who's interested in doing a project, or you have a lake community that has some lake water quality concern. So in this example, I've got a slide of increasing nutrient trends on Shadow Lake. And that's what we have on a number of our lakes and ponds around Vermont, where we're seeing those increasing nutrient trends, or we have concerns around lakeshore habitat. And so those water quality concerns can then lead into doing some sort of an assessment of the lake watershed. So either a lake watershed action plan, or on the individual property owner, you can do the lake-wise assessment. And so it's really important to start out from what's our objective in terms of our lake water quality concerns. And then these assessments help us to identify what projects might be possible or most effective at addressing those issues. And then the next step is often to actually see if the landowner is still interested in doing the project that's available. So as Alison was talking about, not all projects are things that are really going to be good projects for these funding sources. If you have a really small buffer planting project or a no-mow area, those are the types of things that landowners can do by themselves. But if you want to get our funding, you have to do some larger scale projects. And sometimes landowners may not be interested in doing something to the extent that might be required to get our funding. So once you get that landowner interest, then the next stage is doing some sort of design for the project, and then getting funding for the implementation, and then the ongoing operations and maintenance. And I'm going to hand it over to my colleagues to talk a little bit more about that. So when it comes to lakeshore restoration, what I've seen is that it's really oftentimes a pretty significant partnership of different organizations and people in the community that get these projects together. So we often have our lake associations. I've put those in the center here, often a key point of communication in between our property owners and some of the technical folks that are involved in these projects. On occasion, our lake associations may be out writing some grants, but more often than not, we have watershed organizations or natural resource conservation districts that are really leading the charge in terms of writing grants to get these projects funded, as well as overseeing the design and implementation of a number of these projects. And then depending on the project complexity, you may have environmental consultants, engineers, or designers involved in doing that design work. You obviously have your landscapers, contractors, work crews putting projects into the ground. And then we have our DEC Lakes and Ponds staff, so Alison and watershed planners and our lakes and ponds permitting folks that are providing technical support for a lot of these projects. And I definitely reach out, even if you're not in a role where you might be moving one of these projects forward for funding, if you identify a good project out there in the landscape and a landowner is interested, you can reach out to us and we can try to find out what other partners may be available in the watershed to help move those projects along. And then we have our lakeshore property owners. Even beyond this, we often have municipalities, even statewide organizations like Federation of Vermont Lakes and Ponds, our Forest Parks and Rec, or Fish and Wildlife Program. So there's oftentimes 3 or 4 different partners working together to get one of these projects to happen. So just want to emphasize that you don't have to feel like you need to do all this work yourself. There are often resources out there that can help get these projects going. So the other point I want to make is just that we do have a lot of clean water funding. So this is from our Clean Water Performance Report that has just come out recently. And you can see we have over $90 million of clean water funding out there on the ground. So a lot of that's focused on agriculture and wastewater projects. But we also have a lot of funding for our natural resource restoration projects and stormwater projects. So there's a lot of funding out there. And I think there's a real opportunity to do more projects along our lake shores using some of this funding. So just going to do a brief overview of what lake watershed action plans are. So this is something, and Alison's really the lead on coordinating these efforts around Vermont. But these lake watershed action plans are an assessment to identify the highest nutrient and sediment pollution loading areas from the lake's watershed that are impacting the lake quality or habitat or causing habitat degradation. And these lake watershed action plans result in a prioritized list of projects and strategies to address those sources of pollution. And then those projects get put into our watershed projects database, and those are eligible for funding. So a really good way to get projects identified in the lake watershed. So just a couple of maps here, and Patrick Curley's on the call here today. So appreciate producing some of these maps as part of the Lake Willoughby Lake Watershed Action Plan. So just wanted to highlight that these Lake Watershed Action Plans really look throughout the lake watershed, looking at streams, which is the picture on the left here, looking at our private roads and municipal roads. And so looking across that whole lake watershed and identifying a whole host of project types. So things on farms, dam removal projects, river restoration projects, but also focusing on those lakeshore restoration projects as well. And then as Alison mentioned, we also have our lake-wise assessments, which is another really great tool for identifying some of these potential lakeshore restoration projects. And so this is an example with Joe's Pond, where the Caledonia County Natural Resource Conservation District got a grant to do lake-wise assessments around the lake. They identified a number of potential projects where landowners were interested in implementing those projects. They got funding to do some designs and then implement those around the lake. And so this is just a picture of one of those designs where there's some buffer restoration opportunities and doing some shoreland stabilization as well. So there are two main funding sources that can support these lakeshore projects. We have our water quality enhancement grants, and these are focused in the Connecticut and Hudson basins, or projects that have limited phosphorus reduction potential in the Lake Champlain and Lake Memphremagog watershed. Or we have the formula grants, which are focused in Lake Champlain, so in the dark green, or Memphremagog, which is the light green within the red line. And those are focused on projects within those areas that have a significant phosphorus reduction potential. So for both of those, we have some eligibility criteria. And this is based on our funding policy. So those projects need to address nutrients, aquatic habitat, address pathogens or chemical contaminants. They must be consistent with the project type definition, and I'll get into that in a little bit. It needs to be, the project needs to be in our watershed projects database, and then it needs to meet all of our permitting requirements and then have a Department of Historic Preservation review. And we need to have landowner agreements in place to ensure that landowners are supportive of the projects. So a couple things that eligibility requirements for those projects. And here's an example of the project type definition. This is for a preliminary design for a shoreland project. And just wanted to highlight a couple of things. One is that for those shoreland restoration projects, you need to be using practices that are listed in the Vermont Bioengineering Manual. Or if you want to try something innovative, you can check in with Alison and get some site-specific approval for some different techniques. And then for each of these project types, we have specific milestones and deliverables to ensure that the required steps are taken to get those projects into the ground. So just a little bit about the water quality enhancement grants. And so this is the way that we fund our lake watershed action plans and lake-wise assessments outside of those priority, the formula grant watersheds. And we also fund project development, design, and implementation block grants that are held by the Watersheds United Vermont, the Natural Resource Conservation Council, and Mount Escutney Regional Commission. So each of those organizations gets a chunk of money, say about $1 million, and then they put out requests for proposals for which applicants can apply for those restoration projects. Well, on the other watersheds, we have our formula grants. And again, they have a phosphorus reduction focus. And these are led by our clean water service providers that are in charge of leading these grant processes in these basins. And they're guided by basin water quality councils that are made up of some of the clean water experts in each of these regions. So if you're in one of these formula grant basins and you have a project that has a phosphorus reduction potential, then you can work through the clean water service provider funding. And they typically release requests for proposals, at a minimum 4 times per year. So the focus for these formula grant projects is really our Lake Champlain and Lake Memphremagog TMDLs, and I'm not going to go into the details here other than to say that we're really focused on reducing phosphorus loading to these large water bodies, and the formula grants are focused on achieving the non-regulatory requirements. And you can see in both the Lake Memphremagog and Lake Champlain basins, in the Lake Memphremagog and the darker orange, and Lake Champlain, the darker red, the developed lands are a pretty significant contributor to that phosphorus loading, and that's where a lot of the focus for these shoreland restoration projects would be kept. So when it comes to these restoration projects, again, if you're in one of those formula grant basins, you need to figure out if there's some phosphorus reduction potential for those projects that you'd be interested in. So we have a lot of projects moving forward that are shoreland stabilization or riparian buffer plantings. And we have a tool called the interim phosphorus reduction calculator that can be used for that. In terms of private road practices, you need to do a private road, you need to do a road erosion inventory or road assessment to see if the current road meets standards and if you can address those issues. And then with our small scale stormwater practices, we have what's called the stormwater treatment calculator. So I was just going to walk through a little bit of our interim phosphorus calculator tool. This is available on the Clean Water Initiative Grant Resources website, and there's a good online training if you want to dive into this. And it's a pretty simple Excel spreadsheet tool, and the tabs along the bottom are for the different project types. I'm just going to walk through one example of how this tool can be used. And so the practice type that seemed most relevant today was our lake shoreland restoration. And in this example, you just need to fill in 3 pieces of information that are highlighted in yellow here. So that's the length of eroding shoreline to be fixed, the average bank height where that erosion is taking place, and the average rate of erosion occurring on that site. So in this case, we break it up into low, moderate, or severe erosion. And so in this example, we have between low and moderate erosion rate. Or you may have some site-specific information. So the landowner may have a landmark that they know that they've lost 3 or 4 feet over the last 10 years. So you may be able to get a site-specific rate of erosion and apply that in this context. So in this example, if we plug these numbers in of 125 feet of shoreline that's 2 feet high and an average erosion rate of about 2 inches per year, you get an estimated annual phosphorus reduction potential of about 3/4 of a kilogram. And so in the context of our clean water service provider or formula grant funding, the average cost efficiency for those clean water service providers is about $12,000 per kilogram. And so that can provide a little bit of context for what might be a good project moving towards that. So if you were able to do this project for $10,000, then that certainly would be a great project. Even $20,000 or $30,000 would be in the realm of funding for those clean water service providers. But if something like this was $100,000, then that's really outside of the realm of what those clean water service providers would be looking to support. So just to wrap up here, just want to give a little bit of a plug for our tactical basin planning process. One of the roles I have as a watershed planner is to develop tactical basin plans, and I work up in the Northeast Kingdom, so Lake Memphremagog, Passumpsic, and Upper Connecticut. And so we are really looking for support from our external partners as we're trying to identify how to best address erosion. And so for all of you folks engaged in the lakeshore restoration work, we'd love to get your input as we're developing these basin plans for what might be priorities for some of this work. And then also say that as watershed planners, we're a great resource out there for you. If you have a potential project and you're not quite sure how to move it forward, you can certainly reach out to the basin planner in your region. So we have Karen Bates, who's up in the Northwest. We have Keith Fitchie, who's on the call today, I think, covering the Winooski, White, and the Stevens, Wells, Waits, and Pompanuset. And then Angie Allen over on the western portion of the state, and then Marie Caduto in the southeast. So certainly recommend that if you identify a good project and it might not be in your wheelhouse to really move that forward towards implementation, we're happy to meet with you or take that information and try to see if we can find a partner to help move it forward. So hopefully you were able to hear most of that. And
I think we could hear all of it.
Okay, great. After my computer froze on me.
So we had just one question in the chat. So if anyone else has any questions for Ben about funding, please put them in the chat. This question is, can you or anyone else share an example of a project that came from a lake-wise assessment and how it obtained funding for the project? Interested in understanding what types of practices or scope qualified a lake-wise project to be funded by either of the sources you mentioned. And Ben, you could take a crack at it if you want. I can also answer this question.
Sure, I can give just one example, which is the one I presented a little bit, was the project on Joe's Pond. And again, there are a couple of projects there that involve some buffer planting, and they often involved a little bit of shoreland stabilization and maybe in some cases some infiltration steps that were put in as part of those projects. And those were all funded through it used to be called our Design and Implementation Block Grant, and now that's called our Enhancement Grant Program. And so those were a few examples of the projects that we've seen funded most common. And then I think also things like rain gardens and some of those other practices as well that are those smaller scale stormwater practices or other things that I've seen funded through our existing programs. I don't know if you want to add to that.
Yeah, I would say a lot, shoreline stabilization and buffer plantings are probably the most common ones to get funded. Rain gardens and infiltration steps also, especially if they're paired maybe with a buffer planting or stabilization. Those are the ones we see a lot. And then sometimes when multiple landowners kind of go in together and each have a practice on their property under one grant, that can also sometimes be beneficial in being competitive, whether it's with phosphorus reduction or with habitat creation. So, and I'm happy, Bridget, to talk to you more about this in the future if you want to get a better handle on how the Lake-Wise program interacts with the funding sources. Next question. I believe Ben said DEC will pay somewhat of a premium for phosphorus reduction, more than $12,000 for 1 kilogram reduction. Did I hear that right?
Yeah, so it's not so much that we pay a premium, it's not really us, it's our clean water service providers and basin water quality councils that are making the decision at each watershed scale. But generally, yes, if you're achieving about a kilogram of phosphorus reduction for about $12,000, that's kind of the average target that those clean water service providers are trying to meet. So that's just to give you a ballpark range. I think even going a little bit higher than that, they're likely to support some of those. And certainly if you can get under that, they'd be quite competitive for that funding source.
And next question, are there consultants or someone at DEC who would assess phosphorus reduction potential of a shoreline restoration project? I'm not sure if this is coming from the landowner perspective or another person's I would assume a landowner perspective.
Yeah, so I think this is a case where oftentimes it would be a natural resource conservation district or a watershed group that would be, supporting a landowner in trying to get funding for a project. And they may take an initial crack at doing that phosphorus estimate. And then oftentimes, as in my role as a watershed planner, or maybe Alison may provide a little bit of technical support to help figure out what kind of phosphorus reduction potential there might be for any individual projects.
All right. Any other questions for Ben around funding or any of the other things he touched on in his project presentation? If not, thank you, Ben. And we will move right into Jill Sarazen, who's going to talk a little bit about the operation and maintenance agreements when it comes to formula grants. So, Jill, whenever you're ready.
I think I just want to switch my screen. 1 second. All right, everyone see my slides now? Great, awesome, thanks. Sorry about that. All right, thanks, Allison, and thanks, Ben. So as Ben just walked through an introduction to funding sources available for lakeshore clean water projects, I'll talk about operation and maintenance aspects with these funding sources. So a quick introduction. My name is Jill Sarazen, and I'm with the Green Infrastructure Collaborative Coordinator with Lake Champlain Sea Grant, and through the partnership with Vermont DEC Clean Water Initiative Program, I support the O&M program development and trainings, and work with Rachel Wood, Clean Water Initiative Program Verification and Maintenance Specialist, who's on this call right now as well. So she'll be available for questions in addition. A quick outline of what we'll cover today, kind of building upon what both Allison and Ben just set up. Start with a big picture overview of clean water projects, project life cycle, and what does O&M mean and look like. Then we'll talk about the O&M agreement and plan for projects funded under the enhancement grants, and then also formula grants. We have some resources, available trainings, and then any time for questions. So clean water projects, in addition to Lake Shoreland projects, other broader number of projects that have been discussed that enhance and restore water quality across the state by addressing water pollution, excess nutrients and sediment. Clean water projects also provide co-benefits for the environment and local communities. And types of clean water projects are outlined in the CLIP funding policy, as well as the Clean Water Projects Explorer. There's a link there, and you can take a look at other projects funded across the state with DEC funds and other funds. But some examples here: shoreland native revegetation, road erosion mitigation projects, lakeshore projects, and bioengineering, such as those found in the bioengineering manual, and other green stormwater infrastructure projects like Allison mentioned already too. And Ben touched upon the clean water project life cycle. And so we're going to focus in on the last step here, the maintenance side. So the Clean Water Initiative Program funds clean water projects throughout the project's life cycle, from assessment ID to development, design, and implementation. And now under the formula grants, there is funding available to support O&M, operation, and maintenance of these projects as well. So maintenance is super important, and want to highlight what maintenance looks like and how it happens. I think Allison talked a bit about some rain garden type maintenance and other like open top culvert maintenance, and so the life of these projects really depends on the fact that maintenance is happening ongoing throughout the life of the project. I want to make sure the projects are in working condition and in turn function to protect our water quality. It can look like a variety of tasks, some listed here on the slides: stabilizing eroded areas, mowing, removing trash and debris, removing accumulated sediment, replanting dead vegetation. And I'll mention that DEC is finalizing an operation and maintenance manual that will be a good resource on maintaining projects and different suggested maintenance tasks and inspection and verification information is provided in that manual. So that resource is coming soon. And part of O&M is going out to visit these projects to ensure they're functioning as intended. And so DEC refers to inspections for clean water projects that are non-regulatory as verification. So in addition to doing all these tasks, also going out to inspect them and verify their function. So focus in on what O&M looks like for enhancement grants first. Clean water projects funded through CWIP, such as by the enhancement grants, require a 10-year minimum O&M plan that's signed by an O&M responsible party and the landowner for implementation phase projects. This agreement is shown here on the slide. It can be found through the applicant and recipient resources page on the DEC website. This template outlines responsibilities, expectations of both parties. And part of the agreement and plan is a section that specifically identifies maintenance practices and frequency, project type when it's completed at the top there, and contact, as well as contact information for the landowner and who the O&M responsible party is. The O&M manual I mentioned will be a good resource for completing this table, as well as the project designer will be a good resource for guidance on expected O&M practices to include in the O&M plan. So now I'll switch to O&M specifically under formula grants, and those. So the site access agreement, or the access agreement that I just mentioned, is the precursor to what I'll talk through now for the formula grants. So in addition to being a different funding structure, like Ben mentioned, there's this new model of clean water work developed with the clean water service providers, has some programmatic changes, and includes a more formally established O&M plan within what is called the site access agreement. So clean water service providers are required in statute to maintain access to projects that they fund for implementation. The site access agreements are a signed agreement between the QUISP and the landowner that grants access to the project in order to install, verify, and maintain non-regulatory clean water projects that are funded under formula grants. And incorporated into the site access agreements is the O&M plan expectations for what should be activities that should be done over time. There are two forms. It can either be in a license or an easement form. And both the site access license and the site access easement have an initial term that's equal to the design life of the project. And the design life is how long the project is intended to operate for as it's designed. And so that's decided by the project designer as well as some DEC tools. And do note that the site access easements are not the same as conservation easements, and those follow a different process. There's a lot of information on this slide, but is intended to be a resource to identify differences between a site access license and a site access easement. And the two key differences I want to highlight is that a site access easement will run with the land, and it's filed within the municipal land record. The license is not the same, and so if a landowner changes for the site access easement, it remains in place, whereas we would need to re-sign a license agreement if the landowner changes under a license. And the DEC required site access easements are required for projects whose implementation costs are the most expensive, and that's to protect state investment. Accompanying either the site access agreement type is the cover letter, and this is an example of what the cover letter looks like, also found on the applicant and recipient resources page. The cover letter expresses gratitude and encourages collaboration between the landowner and the clean water service provider and other parties involved, and outlines the overall water quality benefits of the project, since that's the first section within this cover letter. And at the bottom here, the section highlighted identifies a landowner liaison organization. So might be certain groups who would be the best point of contact for the landowner and whoever is doing operation and maintenance. And so that group is outlined in the cover letter to accompany the site access agreement. And so this section is important, has some of those more details on how this works. And it informs the landowner of expected maintenance activities and frequency. So these are for the larger scale. Some more larger scale projects would be very important to have all this information included. In addition to the site access agreement terms, there is an O&M plan that includes the tasks and frequency. This is pretty similar to the one I talked about earlier. There's a project description, talks about what kind of project it is, where it's located, some identifying information. And then there's a section on the maintenance and verification inspection visit frequency, required equipment, what routine maintenance activities should be incorporated into the lifespan of the project. This is drafted early on in the project design phase so that all parties are aware of what maintenance is required for the project to continue to function for its anticipated design life. So if you're interested in learning more on when to use each of these agreements and how they work for formula grants specifically, we have a previously recorded training that goes into detail on these agreements. A link can be found on this slide here, and then you'll see the recorded presentation link to view that presentation, and then the templates that I discussed are available on the DEC website, as well as more information on O&M and verification on the DEC website. That is the last link there too. So these will be sent out with at the end of the presentation today. So thank you very much for listening. If you have any questions about the content we discussed, feel free to email either Rachel or myself, and I'd like to thank Alison and the Lakes and Ponds program for inviting us, and hope you have a great rest of your training.
Awesome. Thank you, Jill.
Sharing so I can see. Yeah.
So do we have any questions for Jill about operations and maintenance of projects? I don't think we have any in the chat right now. Does anyone want to ask a question? All right, Jill, you covered everything. There are no questions at all.
Well, feel free to email either Rachel or I. We're happy to talk more. Thanks, Alison.
Great, thank you. Okay, so we have a scheduled break that was supposed to happen at 2. And so we're running about 15 minutes behind schedule. So I think we're going to do like a 5-minute break if you need to go to the bathroom or get a drink or whatever. We're going to start in 5 minutes with Eric Mootz talking about permeable pavers from Travel Trade Supply. right, Eric, do we have you on the call? I think you're here. All right, that is our 5 minutes, everybody. So Eric, if you're there, feel free to share your screen and get set up. Perfect.
Yeah, can you hear me?
Sure can.
Okay.
And you can go whenever you're ready.
Okay. My name's Eric Mootz. I work for Trowel Trade Supply in Williston, Vermont. We're a building material supplier, and we supply everything from masonry, drywall, hardscape materials, as well as ventilated facades and lightweight building cladding, cut architectural stone, kind of all kinds of different parts of the construction spectrum. I specialize in the hardscape part of our business. I've been with the company for about 10 years. I've worked in permeable paving all 10 of those years, and I've worked on various projects from UVM and Champlain projects all the way down to residential homeowner projects. So permeable paving is what we're going to talk about today. And essentially what permeable paving is it's just a variation on your standard unit paving. And the idea of it is that it's able to manage stormwater surge. And so essentially these systems are able to capture stormwater, put it in the base material. So basically have somewhat of like a dry well to store this runoff and storm surge. And then it actually filters and returns that water back to the groundwater. And you can use these for all different types of applications, from residential to commercial to municipal. So Chicago was really kind of the first city in the US that really kind of took this on. And part of that is because of their geography. If you look at Chicago, they have, two major rivers running through the city, and it all kind of funnels into the lake there. And they were dealing with a lot of pollution runoff running off into the lake and the rivers. And so they were very early adopters of permeable paving to sort of manage some of their stormwater surge. And when you go out there, there's even entire baseball stadiums where the parking lots are paved in permeable paving. So Burlington is no exception to that. And I said this on Monday, and I should have done this over the week, but we probably could add a few more pictures to this next couple slides from this past summer. But storm surge and flooding is not something that's uncommon in Vermont, and it's happening more and more each year. This is actually the intersection between Main Street and South Winooski and Burlington, just on the other side of Mr. Mike's. And essentially what causes this picture is these 4 manhole cover or storm drains basically clogged up, and that's what you see the guys doing there, trying to clear it. What could be done in this scenario is even paving just these crosswalks in permeable paving would give sort of a dry well for that water to recede in and sit underground until it's ready to be naturally released back into the groundwater. And those could even be piped and supplemented into the existing stormwater system. And the benefit being that if it goes through the permeable base, it'll actually filter it before it hits the stormwater. So your standard paving detail, or kind of how this actually works, is there's really not much difference between a permeable paver and a regular unit paver. The main difference in what really makes the system permeable is the way the base is designed. In your standard permeable paving, you would have anywhere from 6 to 12 to 18 inches of 3/8 crushed stone, often referred to as a plant mix, which would have fines in it. And then an inch setting bed, typically a sand. And then you would lay your pavers on that sand setting bed and then fill your joints with regular concrete sand. In a permeable system, just the base materials themselves are changed. So typically your last 6 to 8 inches of base is going to be that same 3/8 stone, except it's going to be washed and cleaned of all fines. So it's called a 3/8 clean, or a number, ASTM number 57 is the technical name for it. But it's often referred to as like an open graded aggregate. So it has no fines, and that allows the water to percolate through it. As you get into bigger applications where you need a deeper base, once you go past 8 inches of base material, you supplement with what's called ASTM number 2, or it's often called railway crusher. if you ever walk like a railroad track, and those big sort of like half a palm sized shards are what's considered an ASTM number 2. And again, this is washed and cleaned to fine, so that again has voids for the water to percolate through. And then in your setting bed, that gets changed to an ASTM number 7 or number 9. The best way I can describe it is, again, there's a common theme here. It's washed and cleaned to fines, but it's about the same consistency as like fish tank gravel. And you would use that to screed out and then lay your pavers on top, and then your joints would get filled with that same setting bed material. And all those different aggregates combined essentially give the water a way to come in through the joints, sit in the base, and then percolate back through the groundwater. And there are some variations on this detail that we'll kind of go over later on that can deal with other soil types or areas where you have really bad exfiltration back out into the native soil. And so really what makes a permeable paver is just these spacer lugs right here. A typical unit paver will have no lug on it at all, or typically like a 16th inch lug that helps give you that joint spacing. The sweet spot for permeable paving is right around 1/4 of an inch. So essentially the space between each of the pavers is 1/4 inch. And these lugs can be supplemented with other spacers and other ways to space them out. But you can essentially use any paver, whether it's a bluestone paver, a clay paver, as long as you're maintaining that 1/4 inch joint and the base is developed the way a permeable base should be built, it will act and perform the same way as a specialized quote unquote permeable paver that's from a manufacturer. These are the StormPave HDs. These are really common at UVM and Champlain's campus, as well as downtown Burlington. This is kind of the permeable paver for downtown Burlington. And so we have a couple case studies, and these are a little dated. I'm going to actually update this presentation with some more recent ones, but the Taconic Hotel in Manchester was kind of a good commercial case study. They essentially built their whole pull in and unload area in the porte-cochere as a permeable setting. And you can see them here setting up 18-inch granite curbing and then filling in they're starting with that ASTM number 2 and then finishing out with the screeded ASTM number 7. And so this whole area here, from here all the way around and then eventually out through here, is all permeable pavers. And then the second case study is kind of a unique one. This is the Marriott in Burlington off of Battery Street. And I believe it's Cherry Street that you would come in through this entrance. But this entire installation is actually done on top of a parking garage. And so they essentially built a permeable system on top of a membrane, and then when the water gets through to that membrane, it then goes through and follows the traditional roof, the roof structure to manage its runoff. And so this was the existing that was done in asphalt, and they tore it up and redid it in a permeable setting. And then these are just a couple examples of some private driveways. That's another example of that Pine Hall storm pave, another Pine Hall. And then this is actually a concrete paver. This is the Teco Block Valencia. And this was a private residence, I believe, in Shelburne. And so there's also what's called permeable poured concrete and permeable asphalt. They are not as prevalent as they were kind of 7 to 10 years ago when this was all kind of emerging. This is actually a case study from Champlain College. Typically, what we've found in at least northeastern climates is that they just don't hold up well to rapid freeze thaw, and essentially because they're almost like a honeycomb structure, they hold on to water and then they blow out, which you don't get with a traditional permeable paver, just because it's no different than the classic unique paver. All its densities and absorption properties are all the same, and so this was not what it looked like when it went in. This is a year later, but essentially all of it just pebbled and turned to dust. And they eventually repaved it with a permeable paver, and these are still there today. I believe this was probably 8 years ago now. This is the Perry Hall, the admissions building down at Champlain. And they've done zero maintenance to the project since they've done it, as far as maintaining the joints or anything. They plow it, they salt it, and the system still performs just as good as it did the day it went in. And so many years ago, there was an interest from UNH to sort of there was a lot of questions whether permeable paving systems would perform in northern climates. It had already kind of taken off in the south, and UNH teamed up with a company called Interstate Landscaping, a guy by the name of Bill Gardocki, who's kind of a big kind of spokesperson in the hardscape world in the Northeast. And together they got some grant money and paved a section of UNH's campus in a permeable system. But before they built it, they put in an outlet pipe and were able to measure the water coming out of the system. And this was, they did a big kind of summit after the study was completed. They did it over 3 years. And essentially the study came back that the systems do work in northern climates. They actually do assist with snow removal and ice buildup. And essentially that's because when you have all those voids in the base, it actually creates almost like an insulation layer, like an air insulation layer. And so when the snow does melt, or when you have melting and water on the surface, because it's not pulling on the surface and it's draining through the system, it doesn't refreeze as ice. It kind of drains and gets away from the surface. And the biggest thing they essentially found was when they were measuring the water coming in and the water coming out was that the base in the system itself was actually filtering out 93% of the solid particulates that were coming in. And they also performed zero maintenance on the system for 3 years. And this was actually a photo from the day I went to this summit. And this was a photo that I took the day they did an infiltration test after 3 years. And essentially what that involved was them cutting out the bottom of a 5-gallon bucket, placing the bucket on the pavers and puttying around it. And they would dump another 5-gallon bucket into that bucket and see how fast the bucket would drain. And it was somewhere to the tune of 15 to 30 seconds. And that was with the joints looking like that. I don't remember the exact number, but it's somewhere in the absurd amount of like 500 inches per hour. These systems are able to take in, and really the limitation just becomes how much water can the base hold versus how fast it can exfiltrate out into the groundwater. There's actually videos online. I used to have one, but the YouTube took it down for some reason, where they pull out a fire truck onto a Chicago parking lot that's permeable, and they're just blasting the fire truck hose over it, and the water never gets more than like 2.5 feet away from the spray. There are some advantages to unit paving in general as far as utility repairs go in a municipal setting. All of the pavers can be pulled up. You do your utility work and you can put your pavers back down. It doesn't involve any cutting of asphalt or anything like that. So there is an advantage there as far as maintenance and utility. And there are some alternate constructions that you can do. These are some of these specialty details that for systems where you have heavy clay soils, or the system's designed to take on a lot of water from outside of its own footprint and manage it. So say you have a site where you've got a driveway, but then there's an enormous hill that kind of runs off into the driveway. You'll adjust with a bigger base or so, but there's also, this is a detail where once the system reaches a certain critical limit, it's going to basically run off and run out through a separate discharge. And same thing with this guy is, the system's essentially piped to daylight, so it's being infiltrated, but then it's kind of shedding that water. It's not sitting in the basin necessarily draining to groundwater. There's various reasons why you would do this, and these two details are more of, a civil engineer would come up with these based on site-specific conditions. All of these details I pull are from ICPI.org, or the National Institute for Concrete Paving. I always forget what the acronym is. But ICPI is kind of the national body for all of these standards and details, and they include a concrete curb in every one of their details. That's not necessary and rarely ever actually used. We have a few other options for different types of edge restraint. There's a trowelable edge restraint, and then this is a permeable edge restraint with sort of a netting attached to it, and that just kind of helps it get tied into the system. One of the issues you have when you're using an open graded base is traditional landscape spikes don't like to stay in the base and not move. But there are a few other edging details that you can do to sort of manage that. And then, as I mentioned earlier, this is a traditional concrete paver that's being supplemented with permeable spacers. These are a product made by PaveTech. I've seen tile spacers used, not that I would necessarily recommend that, but there are a whole host of products out there to convert traditional pavers into concrete or into permeable pavers. And in reality, if you're good enough and you can lay them with a 1/4-inch spacing, once your joints are filled in, they'll maintain that 1/4-inch joint without a lug or a spacer. once the joining material's in there and it's all become interlocked. As far as budgets and cost goes, these systems are not cheap. About 5 years ago in 17, 18, 19, typically all in material included, you'd be looking at a finished install rate of somewhere between 20 to 25 a square foot, depending on the material. I would be surprised if you saw a quote under 35 or 40 a square foot at this point. I've even seen some quotes as high as 50 a square foot. Those are sort of unprecedented install rates, and some of that is inflation, some of it is the market. I don't know if those numbers will stay there forever, but the market has kind of driven those rates, and we've sold more pavers this year than we have in the past several years, and the cost doesn't seem to be deterring the market, and so that's sort of part of the nature of the beast. But as far as traditional asphalt goes, you're paying essentially traditional asphalt right now is about 20 to 25 a square foot. Any of the other permeable, porous asphalt and permeable concrete, poured concrete are going to fall pretty similar to what a permeable unit paving system is going to cost. The benefit to unit pavers over, a poured asphalt or poured concrete is that they are typically guaranteed for life from the manufacturers for the material. As far as spalling goes, and even Tecoblock, a concrete paver manufacturer, has warranties against rock salt. And clay pavers will last almost indefinitely. You can get 150 years out of a good clay paver installation, and you can pressure wash it 75 years later, and it's going to look almost just like it did the day it went in. And that's about it for the presentation. Do we have any questions?
There are a few questions in the chat. Yep. And if anyone else has any, feel free to add them to the chat now. But first question, have you worked with Vermont Agency of Transportation for crosswalks?
We don't typically work directly with the state that often. What we'll often end up doing is working with the civil engineers and the architects. VHB is a big firm out of South Burlington, and they tend to be one of the bigger ones as far as like a municipal planning firm. But typically we are working with the architects and civil engineers when it comes to design assist and material assistance.
Okay. So this may be a question for you or maybe a question for Laura, but do these permeable drives count as pervious areas with regard to shoreland permitting?
I believe so. I think that's, as far as I know.
Yeah, by default, we consider all paved and unpaved driveways and parking areas as impervious. But if an applicant is doing a project and they are installing something like this and they share with us their design specs and can demonstrate that it's pervious, then yes, we would consider it a pervious surface. So just, they just have to demonstrate that it is.
Okay, great. And have you ever used decorative concrete blocks with topsoil and vegetation placed in the voids?
There is one paver out there. Let's see if I can find it. That we sell called Turfstone. That kind of looks a little something like this. I have found, as far as so typically pavers are what's called an erosion surface. It's kind of what prevents your base material from falling apart. When you're building, so we stock this product. It's something that's available here in stock by the piece. I have found in practice it is very hard to get grass to actually grow in those, particularly if you're driving on them. But they do exist. You still have to build your base the exact same way as you would a traditional permeable paver. These were kind of the first generation quote unquote permeable pavers, but there's still a market for them and people still seem to like them. This is kind of what I feel like everyone thinks of when they think of a permeable paver. But yeah, this is probably the closest I can think of to that, that question.
Okay, fantastic. Unless there are any other questions for Eric, we're going to move right along. I don't see any others. Oh, there's one more. Can other types of natural stones like bluestone, flagstone, slate, etc., be installed in some manner so as to become considered pervious for SPA %.
Yes.
So there's no reason why it can't. And I don't know if that's something the state has recognized or not, but all that is needed to create a permeable system is the base has to be built correctly, and that 1/4-inch joint spacing has to be maintained, and your joint material has to be the permeable joint material. As far as the actual paver itself, it does not make a difference whether it's stone, granite, concrete, clay, assuming everything else is built to standard. And there was an argument back in the early days that the larger the format got, so if you had a 24-inch by 36-inch piece of bluestone versus a 4-inch by 8-inch brick paver, that you didn't have enough joints to maintain permeability. But again, at the infiltration rates of 500 inches an hour, like if we're getting more than, if that cuts the system down to 100 inches an hour, if we're getting 100 inches hour of rain, we've got much bigger problems than how permeable your back patio is, for sure.
Sure.
So yeah, if that's not something that the state has any specific criteria on, I'd be happy to work with you guys to sort of get something, ironed out in writing that people can refer to.
Yeah, and I think that's pretty accurate to how we review permitting projects. Whatever the material that you use as the surface, it just depends on how it's installed and what's underneath it for us to view it as pervious or not.
Yeah, and that's great.
Yeah.
I love that you guys are following that mantra.
Awesome. And we have one person who has their hand up. Jack, do you want to ask a question?
Yeah, I mentioned the state earlier, whether you work through the state or not. They have a slew of engineers and designers, because you usually only work with them. But like, for instance, in Milton, they're thinking of they got designed to do the whole surface of the road right down to 2 feet. And if you put in some permeable sidewalks or crosswalks, that'd go a long ways to help that flat area get rid of some of that water just standing there. It's all right next to the Lamoille River as well. So
yeah, one of the major things we've found, and I think that a lot of the cities that have really embraced permeable paving as a stormwater control is, you're essentially, if you have an area that does flood and the existing stormwater system just can't manage the surcharge, essentially what permeable installs allow you to do is tackle that one area and just quickly put that surcharge under the surface, and it can kind of sit there and wait until the ground's ready to accept it. And it's a really good way to tackle specific spots like that intersection I showed you in Main Street and South Winooski in Burlington. You can really tackle troublesome spots that have consistent flooding and storm surge issues, and just sort of take that whole floodplain and drop it in underneath the surface, and then let it percolate out at its own leisure, kind of thing, or tie it into the existing stormwater system. But the advantage is you're also filtering it before it gets into the stormwater system.
All right.
excellent, thank you.
Yes, thank you, Eric. I think we're going to move right along now, since we are behind our time a little bit, getting better. But we're going to move on to a presentation by Mike Everhart from EJ Prescott, who's going to talk about some other biodegradable bioengineering sort of products. So Mike, great, you're already on. Here we go.
Yes. And can you hear me?
Yes.
Okay. I'll share my screen. All right. Can you see that?
Yes, but you've got the presenter view up.
Oh boy. How about, let's see. Back out of that. Let's try this again. How's that?
Much better.
All right. My kids aren't here to show me how to use the computer. So my name is Mike Everhart. I work with EJ Prescott. I am their Eastern Erosion Control and Stormwater Specialist. And I'm going to talk to you today about biodegradable erosion control products, especially geared towards shoreline stabilization and shoreline protection. And but one of the key factors here throughout my presentation, you're going to hear me talk about it a fair amount, is the kind of what Alison was touching on earlier. For me, it's all about sustainable vegetation. Vegetation is one of the best forms of erosion control. And so a lot of what we're going to be talking about is different items, tools in your toolbox that you can use to help protect your seed, protect the soil until you can get that germination and that seed root structure to take hold. So I basically cover, I live in Maine, and which you can see, I am from Maine, and but I do cover Maine, New Hampshire, Vermont, Massachusetts, Rhode Island, and parts of Connecticut. So I travel around and get to look at some pretty cool stuff, and get to see some neat sites and different challenges that are out there, and help come up with different solutions. So first thing we're going to look at is coir. Coir's products have been used more and more in recent years. Originally, I did most of my coir stuff was around Cape Cod and Nantucket out on the islands, because it is salt tolerant, and it's all coir is basically coconut husks, and so it's just coconut husks weaved together to create either a matting, or we use it for netting going around coir logs, and the infill for the coir as well. So one thing to look at and understand when you're dealing with coir matting is it comes in different weights. And so depending on what kind of slope that you have, what kind of wave action you're dealing with, and what you're trying to protect, really determines which weight of the matting that you want to go with. So on your right hand side, this is a lighter weight, a 400G mat. Then you jump into the 700. This would be considered a 900, and then this real tight weave gets into your 1000. And so again, it all depends on what you're looking, or what your project is, what you're trying to stabilize and protect. Now, one of the other things that's pretty nice about coir, and why it's being used a lot on shoreline applications, because a lot of times we're using more native species, native plantings, doing plugs or willow staking, and the root systems or the germination process takes quite a bit longer, especially native plants. So you want your matting to be there longer to protect the area as long as you can. And coir will last, coir mats can last 3 to 6 years before it really starts to break down. So that's why you start seeing those, especially when you're dealing with more native species. You want something there that's lasting a lot longer. Getting into the coir logs, very similar. One thing I'll point out here is this netting is either a coir or a jute netting in there. Make sure when you are doing shoreline applications that you ask and request that it has a biodegradable netting, non-plastic netting, because that plastic, they do make coir with the plastic netting, and it basically never degrades. It holds on forever, and you're left with a mess after about 7 or 8 years. So make sure that you get it with the jute or coir netting on there. The coir logs, basically they come in different densities, and the density is how packed, how stuffed the log is, and it's a 7-pound, 9-pound, 12-pound density. And that's just how thickly packed the coir is inside that log. Now, the logs are primarily designed for wave action and wave protection. they're not the same as a filter sock or a straw wattle. There's not a lot of flow rate of water through there. It's geared more towards actually taking that abuse and that absorbing that energy of that wave action. One thing that to point out too before I move on, that we've done a lot of projects where we've actually had people putting in plugs right into these coir logs themselves and had some successful plantings right into the coir on site. But you can see they're pretty simple to install. You just need to trench it out so it has a nice little seat to it and get it staked in properly, and then backfilled. And this is a great representation of putting in a coir log with some lightweight coir matting and then cutting in your plantings in through there. This was actually a marsh area that they were trying to protect the marsh from continuous washout, and they kept losing it over time. And this whole concept is to, when the tide comes up, to splash over, and as the tide goes back down, that this is going to fill back in with sediment and sand and rebuild itself. It's kind of a neat project. And I talked about the plastic netting. You can just barely make out down here. This is actually coir logs going down the bottom here that they had put plugs in, but you can see the actual plastic netting that's still there. And it's a really good idea to use that natural netting on there. We don't want to keep putting plastic in the water. So biosocks, biodegradable socks, and filter socks and straw wattles. So this term compost sock, I wish they had never really started calling these compost socks, because it's not really a compost that's inside it. Those filter socks, it's a wood chip filling in there, that it's a certain sieve size wood chip that is actually sat for a certain amount of time and broken down to a certain component, and then there's several companies out there that manufacture these that are pretty reputable large companies that actually have certification standards for the fill material that goes inside. And the sock is designed not only to help slow down water, even protect against wave action, but it also helps filter anything coming off from a site. So it can filter out on its own. It can filter out TSS. It can also filter out nitrogen, phosphorus, heavy metals, hydrocarbons as well. Now, if you have a site where you're having more concentrated heavy metals coming off the site and heading into a body of water, or nitrogen or anything like that, they have other sock products that are geared more towards that, where they actually add an additive to it that can actually filter out up to 80% nitrogen and like 78% phosphorus, and I think it's somewhere in the 85% of heavy metals. So they have capabilities of doing that. But the regular sock that we sell, or many other distributors sell, they on their own, if it's that certified material, should be able to handle, get removal rates of 40 to 50% of all those different contaminants, which is pretty neat on its own. So it's a good way to protect a site, keep materials from running off that site, but also slow down water. So, we want to slow down water as much as possible. So we're giving that vegetation establishment enough time to take root and take hold. Now, the difference between a filter sock and a straw wattle is a straw wattle looks an awful lot like a coir log. It's basically a straw tube that has a netting or a cotton netting, biodegradable netting that goes around it, and it will slow water down. It's not geared to filter anything. It's really geared more for slope interrupters and stabilization to help you slow water down. So when you're getting trying to vegetate a slope, you can do that. We'll show an example here in a second. This was a unique situation here where we actually did fill a biodegradable sock with what they call a grow media in here. Whoops. That this was not meant to filter or anything. This was more meant to direct. We had a yard that was flowing, concentrated flow down. It was going down over the hill and washing out this hill down to this little brook down below. Well, they have a catch basin there, but a lot of it was bypassing it. So we put a biodegradable sock in there with a grow media in it with a seed mix inside of it. And then the homeowner came in and actually cut holes in there and put little plantings and plugs. So this whole thing disappeared. And then once that cotton netting broke down and degraded, they were left with a natural vegetated berm along the top that would direct water into this. But in the meantime, we needed to stabilize that slope. So we came in and put straw wattles in there as slope interrupters going down. Slope interrupters need to follow the contour. We don't want to have any low points in there. We really want it to follow the contour. This site was hydroseeded with an erosion control mulch. So you have this in place. Now, if any water's coming up over this edge, and as it's starting to gain momentum and pick up speed, it's getting slowed down by these slope interrupters in there. And it's a great way to give yourself the best opportunity for success to vegetate that slope. Puffins. All right. Erosion control blankets. So erosion control blankets were invented back in like 1960, in the early 60s. Two different ways, actually. One came out with a straw blanket. Another one came out as an Excelsior or wood fiber, where it was long strands of like an aspen wood fiber. And then later in the late 60s, early 70s, they started developing a netting that went on there. And the whole concept is, if anybody, I ask this question all the time of, how fast is a raindrop hitting the ground, right? So a raindrop is hitting the ground anywhere between 5 and 20 miles an hour, depending on the size of the drop. So if you think of bare soil and you've got rain coming down, 10, 15 miles an hour, and those drops are hitting that bare soil, it's displacing material, okay? So the whole concept of utilizing straw blankets and even before straw blankets, utilizing straw out there was to help protect that soil from moving from the rain and not allowing the rain to displace it. So you'd actually prepare your slope or your site, you put your seed, your soil amendments, and so on and so forth, and then you put your blanket or straw matting or Excelsior matting on there to help protect that seed and that soil from moving when the rain comes. So once they started creating netting, it was this nasty little plastic, looked like Christmas tree netting that went in there, and they had, single layer nets, they had double layer nets, triple layer nets in some cases. And they did that because of different slope lengths and longevity of how long you wanted that blanket for. So every manufacturer has different blankets for the different slopes that you're dealing with, whether you're dealing with a real graduals like 6-to-1 slope, or if you're dealing with a real steep 1-to-1 slope. They have different blankets for those applications. So it's really important to ask the question of what blanket should I use in this situation that I have right now. Now, Vermont was actually the first state, if not one of the first states, the first state to get away from the plastic blankets and require biodegradable netting. And so they ended up coming out with a biodegradable netting that is either a jute or a cotton netting, and which is fantastic. A lot of states now are starting to incorporate it and call it a wildlife friendly netting. But whether it's the plastic netting, whether it's the biodegradable netting, they all have some sort of longevity to them. And they, you can get blankets that'll last as little as 45 days, and you can get them to last up to 36 months. So it really depends on what you're trying to do and what you're trying to establish for vegetation as well. Again, just like the coir mats, you can cut these blankets and put plugs in there and different things like that as well. That works really well. But one of the biggest things with erosion control blankets, and to have a successful application, is you have to install it properly. And this is where I see a lot of failures come in, because they're not being installed properly. So there are several steps. You prep your slope, you get your seed out there, or any soil amendments, your limes, fertilizers, whatever you're dealing with. And then once you do that, you go about 1 foot to 2 feet beyond the crest of the slope, and you dig a little trench in. And it only has to be a 3-inch by 3-inch trench, but you dig that trench across the contour on the, 1 foot to 2 feet behind the crest. You put your blanket into that trench, you pin the blanket in the trench, backfill it, and then you start pulling that blanket down over the slope, and you're pulling it and you're keeping it tight, because you have to have good ground contact with that blanket to have a successful install. And you pin it based on the manufacturer's recommendation. That is very important, to have the manufacturer's recommendation on the pinning pattern. It could be, 1 pin for every 3 square feet. It could be 1 pin for every square foot. So it really depends on the steepness of the slope, and you want to ask that question. Doesn't matter what the manufacturer is, they all have their recommendations for their blanket. So really ask the question. So, and there's a nice little deer for the wildlife friendly matting, but you can see it's nice and tight going down through there. And that's what we're looking for. Nice tight application. You can see it's buried at the top, so you can't get water coming in underneath it and working its way in there. And by having it tight like that, you're not going to have any twigs or roots sticking up and creating a tenting effect, which can cause erosion coming up from underneath. You can see very easy to cut it around existing vegetation that you want to leave behind. You can come in and cut it and put plugs in there. There's a lot you can do with the blankets. All right, so one of my favorite things is hydraulic erosion control mulches. So this is very similar to doing basically this could be considered like installing a liquid erosion control blanket. You're literally spraying an erosion control mulch on the side of a slope. That this is a mulch that could last up to 18, depending on which category you go, it could last up to 18 months for effective erosion control. Okay. You can handle steep slopes. It can handle, big dips in there. It can handle any twigs that are coming out through, and you can get a nice coverage. And with it, you're actually mixing in this tank. You're mixing in your seed, your fertilizer, your, any type of soil amendments, if it's lime or gypsum to address your pH content, anything like that. It's all in this, and it's sprayed through here. Oh, a moose. So hydraulically applied erosion control mulches are 100% biodegradable. They're 100% recyclable. They're basically wood paper products. These are photosanitized wood fibers that are thermally refined. There's no pathogens or any type of weed contaminants in there, and it is a non-toxic, biodegradable solution. It's pretty neat. I won't bore you with thermally refined versus atmospherically refined. So hydraulically applied erosion control mulches are not quite the same thing as hydroseeding. Hydroseeding is basically utilizing these seeding mulches here for a residential yard, someone's house or a flat area. They're typically made up of paper or cellulose, wood fibers. You can get them in blends. You can get them in straw fibers, and those are geared more towards flat areas. Those are not geared towards steep slopes. But when you get into erosion control mulches, that's when they created. So these products were invented back in the 50s and 60s. And then in the 80s, they started coming out with these stabilized mulch matrix and the bonded fiber matrix. And then in the late 90s, early 2000s, they started coming out with this FGM category or FRM category. And then shortly after that, they started coming out with this engineered fiber matrix. These are all categories that every manufacturer makes. They make those different categories for whatever solution that you're looking for. I will say that over the past 6 or 7 years, they've kind of pretty much just dropped this category off. Everything starts with the BFM. The BFM will handle most of your slope situations. It'll handle, anything up to 2 to 1, 1.5 to 1 in that category. And BFMs typically last up to 12 months. And when you get into a 1 to 1 or greater than 1 to 1, that's when you get up into the FGM category. And I have actually literally had people rappelling off from cliffs that are pretty much sheer vertical out on Lake Winnipesaukee in New Hampshire, spraying FGM or BFM. Seen them doing that as well. So it can handle steep slopes. And what's nice about an erosion control mulch too is if you had a sample of it that had already been sprayed and dried, you could actually wet it under your sink, wring it out, put it on the counter, come back a week later, and it's still going to be damp. It'll hold up to 1,700% of its weight in water. So we talked about straw and the straw blankets and how it protects the seed and the dirt from the raindrops, but it doesn't technically absorb moisture, where an erosion control mulch actually will absorb moisture. So you could have a dry spell, things dry out a little bit, and then it rains, it's going to absorb that moisture. And it's going to help with the germination process with your seed. You'll see higher percentage of germination when you're utilizing an erosion control mulch than you would with the straw matting. So this was an FGM this was actually in Vermont at Elizabeth Mine. We sprayed out there. Came back the next day, went to try and peel some of this off, and it was literally taking the soil with it. That's how much grab it has. It's pretty awesome. And all your seed and everything is mixed in there, so it's not multiple applications. I've done a lot of slopes and these steep bluffs out at down in Plymouth, Mass, where we've literally had guys going over the edge and trying to rappelling over here and hydroseeding and because these are sensitive areas, not just because of water body, but because of nesting birds in these slopes. Now this is kind of interesting here. It's hard to see, but this area here is one house, and this area here was another house, and same contractor doing the job at the same time. This homeowner wanted to use erosion control mulches going down through with blown straw at the top. This homeowner wanted to use a FGM or an FRM erosion control mulch going down through here. These jobs were done at the exact same time. You can see which one was more successful than the other. So this was actually on the Saco River up in Conway, New Hampshire. Just threw this in here just because I wanted to say that when you're dealing with native seeds and native mixes, a lot of times you have to have some sort of cover crop in there because some of them take so long to germinate. You could be a year or 2 years before it germinates. And this was a house where they put a pretty heavy amount of cover crop in there, and there's a little too much cover crop in there. They did eventually end up getting some natives popping up through, and then came back, and this was a hydroseeded slope. They came back and actually put in some plugs in here. I just went out and looked at this 2 weeks ago because of the massive rain events that we had in Maine and New Hampshire a couple of weeks ago. And the water level came up to here from the Saco River, and not a stitch of this moved. And it was pretty impressive. And I got to include those slides in there and show that sometime, because it's really impressive where that water level came up to, and the fact that none of that moved. So talked about best form of erosion control. The best form is sustainable vegetation. Okay, not just vegetation, but sustainable vegetation. We want to get, sustainability comes from the nutrient cycle, right? So anybody can just throw out grass seed and get something to come up, but is it going to come back next year and the year after and the year after? What we want to do, and what I want to do, is make sure that your soil is healthy and that we can get this vegetation when you're trying to stabilize a slope, that it's stable not just this year, but for years to come. Okay. And I don't want to just fix that and stabilize that slope. I want to make that soil healthy so it can continue to grow soil. So one of the biggest things to do is to get a soil test done. It's so important to get soil testing done. We need people to utilize soil tests, look at what's your organic matter, what's your pH levels, what's your soil content breakdown, the percentage of sand, silt, and clay. Look at your total CEC. We need to understand that soil so we can actually make an accurate recommendation or prescription for that soil to make it healthy soil again. I do soil tests all the time. I provide free soil tests, and with that, I give recommendations on what to do to get that vegetation established and to stay healthy. But I like it to going to a doctor's office and you have a sore elbow and the doctor automatically schedules you for surgery and doesn't run a single test. It makes no sense. And same thing with soil. Your soil is your foundation for your vegetation. So let's take a look at it. I am a firm believer that organic matter matters. Okay, so we got to look at the organic matter. If we are getting soil tests coming back with 1% organic matter, we have to do something to it, right? So let's take a look at that and let's put some additives in there. There's natural additives. There's all kinds of things that you can put in there that aren't chemicals, and to rebuild that. We have stuff that runs through a hydroseeder. There's products out there that are called biotic soil medias or biotic soil amendments, and they are basically a topsoil replacement. It's an engineered soil media, and it literally has stuff like bark and wood fibers. They have biopolymers, biochar, seaweed extract, humic acid, endomycorrhiza, They have beneficial bacterial microbes that are in there, which is wicked cool because they're literally feeding, once they activate, they're starting to feed off from the wood and bark fibers in there as their thatch until the vegetation gets established. But what's cool about this is time and time again, I've done soil testing on projects where we've had 1% or 2% organic matter. We've put a biotic soil media in there, came back a year later, and we've increased the organic matter by 1% or more in just 1 year. Come back 2-3 years later, you're seeing 2-3% higher organic matter than when we started. It'll continue to grow and it'll continue to build that ecosystem in that soil structure. And that is so important to get sustainable vegetation. I'm just going to run through a quick couple of projects. This was a project, a sensitive brook project where they actually moved Brandy Brook. This is in the state of Maine, in Gorham on Route 25. They literally moved a brook, Brandy Brook, from one side of Route 25 to the other. We went in there and we hit it with a biotic soil media, which the guys weren't too thrilled about, having to hydroseed everything around these plantings. They thought those plantings weren't going to be there until after they were done. But they put the biotic soil media in there and then they capped it with an erosion control mulch. We actually talked to the DOT and asked them if they wanted the weirs vegetated going in through there. They thought I was kidding. And I said, no, I think we could probably do it. So we did it. So this is what it looked like about 10 weeks later. And you can see, blow that up. We got vegetation established on those weirs, on those little rock weirs. So, and this was up in Maine on Madawaska. This is up, this was actually a DOT rail project. You can see they had to move the rail. They were losing this edge. This is the St. John's River. So that's Canada right there. We hit it with a biotic soil media, capped it with an FGM. This was literally like less than a week later. We actually had a 5-inch rain event in 2.5 hours up there. And you had moose tracks going up over the side of the hill and not a stitch of it washed away. And then this was like 6 to 8 weeks later. So it really works well with getting vegetation established. But what's great about it is coming back to these sites year after year after year, and it's just as thick and plush and green as you could ever imagine. Now, one thing that's not a biodegradable solution that I'm going to show you real quick, but this is designed to last 120 years. In fact, the ASTM design lifespan says it's 120 years. When they actually did the testing, they came out to 240 years. But there's a way when you get into these really steep situations and you need to build a retaining wall, there are ways to do vegetated retaining wall systems, okay? Where you don't have to have a concrete block retaining wall. This is the same, you design it the same exact way that you would design it a block retaining wall. You would have the geogrids going back in through here in different lifts. These are actually a bag product with a sand media mix inside there. And then they have a plate that locks it all together as it goes up the slope. You can do up to 65, 70 feet high, straight vertical with these. You come in, you hydroseed it with an FGM. You can actually cut it, put plugs in it. You can layer in willow stakes in between the layers of the bags as you're going up. You can do live staking right into the bags, and you can get a nice vegetated wall system that you can go pretty much sheer vertical. It's a pretty neat system. It's something that I've been following for a number of years, and this company is based out of Western Canada. And they're just now starting to move into the Northeast. And we've got a couple projects coming up, one in Dover, New Hampshire, that's under construction right now. Another one down in the city of Providence, Rhode Island, and another one up on a lake in Maine that they're getting ready to start. So this is a pretty exciting way to get a structural vegetated wall system, and I'm pretty excited about it. This is just a shoreline application that they did up in New Brunswick. Literally have it stacked up. They're actually hydroseeding it, the face of it. They came back and put a bunch of plugs in there, and then this is what it looked like a couple of years later. So it's a good opportunity to get a nice, and you can put natives in there. You can do any type of plant species you want. And this is just that one I showed on that original slide, but it gives a little bit more detail. And starting around that little stream area, shows them layering it up. There's the geogrid, the backfill, and they're literally going up over that giant culvert, and they create this beautiful vegetated slope system. So that's it. I thank you guys for listening to me. If there's any questions, feel free to shout them out.
Yeah, we've got some questions for you in the chat. So let's see here. The first one, I think this was about, might have been erosion control blankets. Should you run the blankets parallel or perpendicular to the slope?
So typically you want to use them vertically, but you can do them horizontally across the slope. If you do horizontally across the slope, you want to start at the bottom and work your way up.
Okay. And then another person, can the erosion mulch handle sand at a 1-to-1 ratio?
It can handle, well, I have done slopes that are 89% sand. When we did the soil test, it had 89% sand and a little bit of clay and a little bit of silt mixed in, and we handled it just fine. We have done some slopes. We have sprayed some slopes with that were literally 100% sand on Cape Cod, and we were able to get vegetation established, but it was very difficult to keep it established because of the fact that it was sand.
Yeah, that can be hard. Mike, can you talk about your experiences with very steep or inaccessible slopes on shorelines?
I can. So like I had said on Wind of Saki, we also did it down in Plymouth, Mass, where I have literally had people rappelling over the cliffs, hydroseeding the slopes. And we had one site in Plymouth that actually had a large overhang that I want to say it almost went out 7 feet. There's just massive overhang, and it was about 200 feet. It was a little under 200 foot bluff. And we had a gentleman hanging over the side of that hydroseeding, and he literally sprayed up underneath that overhang, and we were able to get vegetation growing upside down.
Wow. A little further down, there's maybe a similar question. Are there any products that you're aware of that will work on a near vertical rock face along the shore of a lake to keep erosion from occurring at the top of the slope?
Yeah, so rock faces are a little bit more difficult. We can hit them with an FGM, but you're having a very difficult time getting vegetation to establish in that case. So to keep the material up there, you almost need a combination of things where you might want to come in and hit it with some sort of mulch. And then actually, the trick is, if you're going to use a blanket, you need to be able to anchor it somehow. And that would be something I'd have to take a look at and see what I could come up with for solutions for you.
Okay. Can you provide a spec sheet with various prices per square feet for different mulch and control treatments?
I certainly can.
All right. I don't know if you want to give that to me and I can disseminate it.
Sure. Sure.
All right, yeah, that'd be great. What was the name of those stackable bags?
So that's a product called Flex MSC.
Flex MSC. All right. And last question that I have here. I may have missed something. Are you using ground staples to secure erosion control blankets? And if so, are they biodegradable?
So we are using ground staples, and they do have biodegradable wood. They're actually a wood stake is what they call them.
Mhm.
So it is a biodegradable wood stake.
Okay. Fantastic. Unless there are any other questions for Mike, I think we'll move on to our very last segment of the training. So last chance for questions. All right. Seeing
Well,
none, thank you, Mike. That was great. All right. So when we do this in person, we now do a little group project sort of thing, but because there's over 100 people on this call, instead of doing this as a group, we're really going to sort of just walk through the idea together, and maybe we'll have some questions that people can jump in and answer, or maybe we'll just talk it through. But Laura is going to lead us in this shoreline development design review and summary.
Great. Can you guys hear me and see my slideshow?
Yep.
Okay, great. Yeah, I was kind of thinking I'll just kind of talk through and, maybe give you a moment to think. You could put things in the chat, or if somebody wants to add something, that's great. But the goal of this is to take all the information that we received today from the importance of ecological protection of the shorelines and the regulations and the best management practices and bioengineering and put it into practice. So we're going to look at a couple different parcels, and these are real world scenarios. And we're going to think about how to conduct some lake-friendly development in those places, think about what kind of best management practices we'd want to install, how to stabilize eroding banks, and then also think about the regulatory implications. So, just a reminder about the Shoreline Protection Act standards. I can also kind of touch base on that as we get closer to that. There's a whole suite of different types of shoreline best management practices, the vegetative and the structural. Probably a lot of you are familiar with these anyways. But we'll start, I've got 3 examples. And this is our first example. This is a parcel that was developed long before the Shoreline Protection Act went into place. It's got a public road within 100 feet of the shoreline. It's all what we would call non-conforming. The parcel as it is now already exceeds the 20% impervious surface threshold, or it's right there. So any proposed expansion would require best management practices. It's already above the 40% cleared area, and it's kind of a small parcel, relatively flat. It's got 100 feet of lakefront. So this is what they're proposing to do. They want to expand their home and to put in a driveway turnaround. Here's their leach field area. They, you can see off here on the side all the different expansions they're proposing, which is going to bring them to close to 30% impervious surface. So in order to permit this project, we would have to offset 1,150 square feet of new impervious surface. And then they're proposing to remove about 1,000 square feet of vegetative cover. So we're going to have to offset that. So if you guys want to kind of think about how you would make this project lake friendly, what kind of best management practices you would use, maybe if you want to put a couple things in the chat. I can't see anything right now in this presenter mode, but
I can.
Okay, great. I'll just give you a minute. And let's see. Okay, I'll talk about what you know, obviously there's not one correct answer, but, you know, one thing we could do is install gravel drip line infiltration trenches around the entire structure and garage. We could, instead of doing an impervious turnaround area for the drive, that could be installed as pervious. So they're not creating as much impervious surface as they originally proposed. There could be a vegetative swale along the driveway. And then we would replace a minimum of 1,000 square feet of vegetation closer to the shoreline, and just leaving that kind of narrow access area as in the area right around the house as like their access to the water, their view, and a little bit of lawn space. And obviously we have to be careful when we're thinking about infiltration practices near leach fields. We don't want to drain all of our water into a leach field. So we'd have to make sure that those trenches were at least 20 feet away from that leach field area. I don't know, Allison, if there's anything else in the chat that you saw that you think is worth highlighting, or
Nope, there wasn't really much in the
Okay.
chat.
Okay. So these are kind of like real world scenarios, and we're gonna jump over to the shoreline now. As you can see, there's a bunch of broken up riprap as we're looking at it in this plan view. But when we take a look at the profile view, you can see that the riprap is kind of broken apart. It's not very effective. It's got an eroding bank and it's steep. That's a 2-foot drop off. And so to stabilize this area, there are a couple different options, but this riprap is not very effective as it is. It's probably small and undersized, and it's not really providing that sloped character. So creating some sort of 2-to-1 or 3-to-1 slope to get more dissipation of wave energy and establishing some vegetation at the top of the slope would probably be a really good approach to stabilizing this shoreline. That would need a lake encroachment permit. The project that I showed you here, all that would need a Shoreland Protection Act permit. I think that goes without saying, but I have to say it. So, you know, the house is pretty close to the water, so there's probably a great deal of runoff and erosion that is being caused from that development. So reducing the grade of that slope and establishing vegetation is a good option. Here's a natural stone approach that also there was a bunch of vegetation planted on top. So that's kind of an example of what we'd be looking for. Okay, so here's example 2. This is a non-conforming parcel that was created back in the 70s. So it's got that like legacy ability to be developed, even though it's not quite 100 feet deep. It's pretty steep. There's a saddle kind of in the middle that seems like prime development area. Everywhere else is pretty steep. But the problem is that flat area is pretty forested and the rest of the lot is mostly cleared. Even though it's not developed, it was mostly cleared long ago. In order to, what's being proposed is to develop a home on this site, and to put in a driveway and a leach field. So those trees would have to be removed and they'd have to put in new impervious surface. The impervious surface of the driveway and the house are under the 20% threshold for total impervious surface, but they're way above the allowance for cleared area, and it was like that before development. So if you want to think about how you would make this property and this proposed development more lake friendly, what would be needed to authorize this? What kind of practices would you install? So, you know, because they're below that 20% impervious surface threshold, it's not required that they install impervious surface BMPs, but this is such a steep area that we would probably require multiple best management practices to deal with the steep slope and the erosion from that. So there's only one acceptable best management practice for proposing the removal of vegetation, and that's revegetation. And we're trying to get it as close to the water as possible. So it'd be a minimum of 1-for-1 replacement on that of vegetation, and we'd be getting it on the slope. That will help with a lot of erosion and runoff from the new development, and just to help that steep slope stay stable. The driveway is on a steep area, so we would probably require the installation of water bars across the driveway that direct water into vegetated areas, or perhaps even like a rock-lined swale, just depending. We would install a meandering 6-foot wide footpath to kind of keep traffic minimal across that steep slope. We would use native plants, and then a drip line infiltration trench around the roof line of the home. So now we'll zoom into the shoreline here. You can see that there's some broken up concrete on the side, probably from an old remnant wall from a neighbor, and some, looks like some riprap again. That's kind of broken up. This is the profile view, and you can see it's a pretty long, steep run. So having that vegetation established here is going to be really important. You can see the bank is undercut, and this is, to do the stabilization all with riprap here, you would have to achieve that 2-to-1 slope. You might end up going out pretty far into the water. So this is actually a great scenario for encapsulated soil lifts, because you can stack them in a way in that undercut area and establish more of a natural shoreline without so much rock. I mean, you do have a rock toe, but I think this is an appropriate fix for this area. I guess I'll just take a second if anybody had any comments or anything they'd like to add about this site.
There were a couple good ideas in the chat about revegetation of the shoreline and other things. If anybody wants to speak up, who put something in the chat or otherwise, please feel free to actually talk, because this is a little bit hard to do with just in the chat. Some talk about moving the leach field, or maybe putting some plants on the leach field. No, I'm sorry, the plants on the leach field was the first one.
Yeah, I think that Vermont requires that leach fields are lawn.
Yeah, I think it was like a wildflower kind of a deal. There's a question here. Is that an existing rock toe? Should it be built up? Is that not necessary?
Here there is, and I think that if you were going to install encapsulated soil lifts, that you would need to build it up somewhat. Again, this is just some old riprap that's not very effective at stabilizing the shoreline or preventing erosion. But stopping mowing on this steep slope is probably going to be one of the best things that can be done, and then stabilizing it with some sort of gradual sloped vegetative solution will work.
Yep, that's what most of these comments are saying. Similar thing.
And so here's our final example. And this is, an excellent, I'm just going to go back and say that those encapsulated soil lifts, adding the stone toe, would need a lake encroachment permit, and the proposed development on that undeveloped lot would require a shoreland permit. Okay, so on this final example, this is a really excellent property. This is a property that could have a Lake-Wise award. It exceeds the standards. It's got a lot of vegetation all up on the shoreline. The camp is set back. You can see there's a neighbor's seawall that's probably causing a little bit of erosion at their shoreline. But they have these neighbors that live on the other side of the road, and they cleared their hill, and all this runoff is running down. And so they're experiencing erosion near their house due to development pressures outside of their parcel, outside of their control. And this red line is, I believe, the protected shoreland area. So it's outside of the protected shoreland area. So these neighbors didn't need a permit to clear there. And this is a really common challenge we see, is how to manage things that you have no control over. So the challenge is really to how to redirect and infiltrate this runoff so it doesn't threaten the house site or their leach field, because they both need to be protected from runoff. So there's a couple different things that could be done and installed. It's also a great opportunity to get to know your neighbors and maybe show up with some muffins or a 6-pack and offer them your kind thoughts on how to protect the lake, if they're receptive of that. There is this small stream also on the property, but so one of the suggestions is to maybe have a vegetated berm or swale around the perimeter of the camp, to prevent runoff from impacting the house and the leach field. And also over here by the driveway, installing a culvert under the driveway to redirect the runoff from the swale into the vegetated area. So that's one idea. Also buffering more of that stream may be helpful. And then here's the shoreline. So if you remember here at the south end of this image, you can see that they're experiencing some scouring from the neighbor's seawall and some erosion. So here's kind of an image, and they've got a big, nice tree there that's in danger of falling over from that scouring action. So we generally really focus on all the upland practices that cause shoreline erosion. That's our primary focus, and that's usually the reason that shorelines become destabilized. But sometimes you have a really nice vegetated shoreline, like in this instance, but you still have erosion present. And sometimes that's from just natural causes, and sometimes it's from neighboring properties, being right next to a seawall or poor development can cause that. This could be a really good situation for fiber core logs to prevent that tree from falling in, stabilizing it. And then, I just want to point out there's this log here, this submerged log in the water. That is part of the public waters. It's part of the public trust. It's public property. It belongs in the lake. It's for the fish. So we don't really want you to pull out any kind of existing logs that are in the water. They have an important purpose. So that should stay there. So yeah, fiber core logs. And then we take these 3 parcels, and they actually in real life are all neighboring parcels to each other. And, this is just an important lesson that we all can remember when you're living along the lakeshore. There's all these tiny parcels, and we review projects on an individual level. We review permits. We look at all these projects on parcel by parcel level, but it's all the sum of all these little parts, and everything that happens on one parcel affects the other parcel, and we're not working in a vacuum. So all these projects are interconnected, and they all impact that same water body. So, this just the lake-friendly practices help preserve your property, but they also are part of the larger picture. And that is the end of this slideshow.
All right, great. Thank you, Laura. Thank you, everyone, for being here today. This is the end of the training, so this is your last opportunity to ask a question while we're here. I also put in the chat a form for you to fill out if you should so desire with feedback on this training. open it now, but you don't have to fill it out now. We've all been staring at our computers for 7 hours, and I wouldn't want to fill out a form right now if I were you. But please do the coming days. I'll include the link to the form in a follow-up email. And I'm happy to hear any of your feedback for how to make this training better in the future. There's a question from Tracy in the chat. How does one become a Lakewise assessor? So in order to be a Lakewise assessor, you have to attend the Lakewise assessor training that's held in May annually. And that is only open for natural resource professionals and not for like the lay person. So you would have to be a consultant, work for a nonprofit, an NRCD, state agency, something like that in order to be eligible for that training. I cannot answer their question, Jeff. Can you talk about the difference or effectiveness of Quare logs versus Quare blocks? I don't think the people who would be able to answer that question are on this call anymore. Are landowners, lake associations paying out of pocket for private assessors? Is there funding somewhere for that? Abe, do you mean Lakewise assessors? Generally speaking, no. So Lakewise assessments are offered free through the state of Vermont. That's me in my office. If lake associations wanted to, they could contract independent assessors. But generally speaking, they're either done through grants or through my DEC office, and they're free. So I think that there's only one lake I can think of that had contracted specifically with their own money to have Lakewise assessments done, though they could do that with a grant also. All right, I don't see any other questions. Thank you all for all of your thanks. Oh, here's one. What is your view of using chemicals to control nuisance aquatic plants? I am not the right person to ask that question. I don't work with aquatic plants. Yeah, all right. Thank you, everyone. We're ending 10 minutes early. That's amazing, considering we've been about 15 minutes behind since this morning. So, all right. Thank you all. Have a lovely evening, and don't forget to fill out the feedback form. All right. Thank you, and goodbye.